Hi everyone, I'm Guillaume Tucker. So this talk is about KernelCI. Who is familiar already with KernelCI? Can you raise your hand if you know? Okay. Good. This looks a bit like science fiction, but it's a real project about real problems, trying to solve things like testing the Linux kernel. So, of course, some people are testing the Linux kernel already. So you have individuals, like developers, maintainers. People have their own platforms that test their code on their platforms. Then you have like downstream people, like users and distributions, who will, and equipment vendors who will test things on their own products and make sure that works, but always very targeted at the things that they really care about. And sometimes they send fixes upstream, but it's like a second priority most of the time. Then you have more wider projects about testing in the upstream Linux kernel, like the Intel 0-day and the Intel Linux kernel performance systems. So they build actually a lot of kernels on many architectures, but the tests are mainly about the Intel x86, which kind of makes sense because that's run by Intel and they care about having their platforms to work, working in Linux kernel. Then you have Linaro kernel functional tests. That's mostly working on the Linaro member platforms like 96 boards and overall on ARM platforms. There are a couple of exceptions. There are a couple of x86 boards and other things in the LKFT. But again, it's driven by the Linaro motivations, which is to test on their platforms. And it all makes sense because that's why these organizations were set up for. So basically what you end up with is that there are things in the kernel that are very well tested because people care about it, and then you have other things that people don't really test very well. So you have the total test coverage. If you look at all the code, all the APIs, all the drivers in the kernel, you have some things that are really well tested and some that are not. So it's always the same things that are being tested. Now, if you look at what KernelCI is trying to do, is basically go off-road a little bit. So try to test the other things and try to bridge the gap. So the actual power of KernelCI is to apply the same idea of free software but to testing. So you have different people running different tests on different platforms. If you combine them, if you make your hardware available to others, if you make your test available to others, you can have your test running on someone else's platform, or you can have the other way around, so people can exchange things, and then you multiply the number of things being tested. So that's how you expand the test coverage. And it's really targeting, so in upstream kernel, everybody contribute the code in the same place. That's the idea of KernelCI, is to have one place to test all of this together. So maybe people are starting to know a bit more about KernelCI, but it started in about actually 2013. I'm not an expert in the history of KernelCI. There are some people here who started it. I joined in 2017, so I'm more like, this is what a lot of people think about KernelCI. If you go on the Linaro website, it says, it says it was a Linaro project in 2014. Of course, it originally targeted mostly the ARM ecosystem, and did build and then boot testing, but not more than that. And for a long time, it didn't have a mailing list. It was hard to understand, how to know what was going on there, and it happened pretty much under kind of closed doors. But now it's starting to move again, but it needs a new home. So right now, it's not, it's really tied together in a very loose way, but we are hoping that this project will become part of the Linux Foundation very soon, and that will give some structure and organization around it, as well as sustainable funding mechanism via some membership scheme. So Collabora, I work for Collabora. We were committed to become a primary member of that project. So like I've explained, it's about filling gaps in kernel test coverage. Some big companies have already provided some servers. So we know that there is some interest around in different kinds of businesses. So it's not just embedded, it's also like, in the cloud business as well. And so hopefully that would give us more sustainable funding, more sustainable structure and infrastructure as well. I didn't put here. But right now people are giving servers, giving hardware, but there's no contract. We don't really know how long going to keep doing that, and if something changes, we can't plan things ahead. So if we want to say, no, we want to build more trees, maybe we can now, but who knows if we'll still be able to do that in 6 months' time if we have fewer servers. So hopefully that will help with the project. So that was kind of a summary of where the project is coming from. Hopefully I'll have a bit of time for questions at the end, so I'll go through the next phases. If there's something here that doesn't make sense, please stop me and I'll try to clarify. So where are we now with KernelCI? So that's a summary of what it does. So you have developers, people making changes in Linux. So they push some changes to that's typically maintainers, but it could be individual trees as well. There's about 100 branches that are monitored by KernelCI, some from mainline to individual developers. Then that will be detected and built. So there's various kinds of servers. Normally it's all managed by Jenkins at the moment, and then all these kernels are tested to see if they boot, and also we have some functional tests. I'll come back to that in a bit. So most of the time it's using Lava to test all these kernels and capture the results. There are a couple of labs that are non-Lava, so it's possible to include other things in KernelCI. And then the results are stored in a database. There's some processing done as well to detect regressions. So if something worked on one kernel revision and failed in the next kernel revision on the same branch, then that's detected. And right now we also have automated boot bisection. So if a board booted and doesn't boot, there's a bisection run, and if it succeeds, it will send an email with the commit that it found and some details. We're starting to add this for all kinds of tests as well, not just for boots. So that's basically what you get. Then emails telling you what built, what was booted, what failed, regressions, and bisection results if it finds them. And a dashboard. So there's a web dashboard on KernelCI.org, and we're hoping to develop other kinds of dashboards as well, because the one we have is kind of aging a little bit. In numbers, so yeah, we're building and booting millions of kernels, but it's hard to deal with big numbers. So basically, on average, there's a new kernel being built every 24 seconds as an average, if you look around the year, and one board is booted every 40 seconds. We have 76 device types. We have more devices than that, but these are different types of devices. So sometimes we have 3 Raspberry Pis maybe, but that's the number of different pieces of hardware. And these are the main labs. There are some other smaller labs as well, but these are the main labs. And these are the architectures that we build, so quite almost all of them. We are testing on most of them. I hear Kevin is just about to get testing on RISC-V as well, so cool. We're not testing on Arc yet. Yeah, so basically we're almost covering everything. It's growing all the time. So yeah, about boot bisection. So it's currently run on mainline and stable branches, Linux Next, and some subsystems and maintainers tree. I've put a few links here if you want to see. These are all the ones, the more recent ones. This one was actually the first one when it was the commit in the fix said reported by KernelCI bot, which was quite cool. If you look here. But the others were reported manually. So initially we would let the bisections run and look at the results, and if verify them, curate them by hand, and if they look good, then we would forward the report to the people. Now it's working out the recipients automatically based on the code that was changed, and also of course the author of the commit and all the trailers in the commit message. So functional tests, these are the things we are running, so we're not running them intensively yet, but we're starting. So for IGT, we're running a subset of them, the common subset that's architecture independent. I mean, it's not just Intel, that's the DRM KMS. It's about, 100 test cases, I think, on a few platforms. We're not really sharing the results too much, we're just starting with that. And we're hoping to grow this in the next few months. For media subsystem, the V4L2 compliance test suite, we're running this on Vivid and UVC Video on several hardware platforms. And we're working with the media subsystem maintainers to get the best, well, find the best way to run the tests and to report the results. And actually, I was talking to Hans Berkwiel this morning about how to improve that and how to expand cover. So there's good interaction going on here. It's like the first subsystem where we're actually having this kind of collaboration to get some real good tests working in automation. And we're hoping to then expand to other tests, subsystems quickly. We're doing some suspend resume tests and USB, some basic ones. There's plenty of things we could do involving hardware automatically plugged and unplugged. We're not quite there yet, but it's the kind of things we could do in the future. So yeah, what's actually next? What's planned to happen next? So like I said, we're hoping to be, for KernelCI to become a Linux Foundation project. So with the membership scheme, you would have people subscribing and providing funding this way. So I mean the details are not all. I don't know about all the details, so I don't really know if it's going to be, from an infrastructure point of view, if people will still need to contribute their own infrastructure, if people are going to be hired. I guess everything is possible. But what is sure is that it will give some sustainability and some stability for the project. And yeah, we're still waiting for the project launch. So stay tuned, see what happens. More build power. So yeah, we've got some builders from Microsoft and Google, and I mean Collabora provides some builders, and Bay Libre and some KernelCI founders as well. So what we can do with more build power is build more trees. So that means we can build subsystem trees, more subsystem trees, which means we can, and test them as well, which means we can catch problems before they get merged in Linux Next or in mainline. Because there's a lot of trees we're not testing now. We're not testing at the moment, and it's especially the kind of trees where people test on only one or two platforms, because it's not very widespread at that point. So if we could do that, then we would reduce the number of failures further down the line. So it's easier to catch problems early because you have fewer changes. You could even test each commit on a branch which doesn't change very often. So maybe in future we'll not even have to run bisections if we find all the problems on the subsystems, unless it's an integration problem, which happens in Linux Next. And of course we can add support for multiple compilers, and we've got that almost running now, thanks to Matt over there. It's funny, about 4 years ago I went to a Linaro Connect presentation about KernelCI, and the only question I asked, I said, can you choose the compiler? And then it was merged last week, so that's pretty cool. So yeah, we're adding GCC 7 and GCC 8 and Clang 8 on some trees on Linux Next, on Intel and ARM. And here there's some concept I came up with. So you have like horizontal and vertical testing. So KernelCI is good at testing small things like boot, build and boot on a lot of platforms. And then you have other projects that are more like vertical integration. So I took LKFT, you have others, but LKFT is typically about running long things like Linux test project. If you want to run the whole suite, it takes hours, but only on a few platforms. And if you kind of combine the two, of course, maybe you won't be able to run all the tests on all the platforms, but at least it gives you more possibility. So if you have the capacity to run all the tests, then it's just a question that if you can scale, if you have enough devices and lab time, then you could, in theory, run all the tests everywhere. So that's the kind of idea I was trying to explain, where at the beginning gives you more possibility. And yeah, expanding tests. So that's basically trying to walk everywhere on, this picture of the beach where everybody's walking on the same thing. The idea is to be able to walk everywhere and discover the whole place. So I was talking, like I said, I was talking to Hans this morning. There are some areas of the kernel that don't even have a test suite, and these could be tested. And yeah, I mean, some areas have a test suite. Of course, when it's a hardware thing, you can only, like a driver, you can really only test it with the driver. But there are some things even that could have, like a framework test, an API test, or something that could be,
Should is the word. It should.
Yeah. Yeah. No. Also, what's really important is, I've been working with Hans, for example, on V4L2, but KernelCI people can't fix all the problems. It's infinite. So what's really important is to enable other people who have a board to submit it or a piece of hardware, or have a test suite and make it work within the KernelCI project. So there's two ways, I guess, to facilitate that. So having a standard way of running things in KernelCI so people can make the test work with KernelCI. And also we can help integrating things as well. So it kind of comes both ways. So if you have a nice test suite that doesn't run in Lava, we can make it maybe work in Lava. This kind of interaction has to happen. And of course, there's very little standard in test results formats, and that means every test suite needs a special script or something to parse the results. That's something that would be really nice to have as more standard. And the most crucial thing is to be able to rerun only the smallest piece of the test suite that actually failed, to track things. If you want to run a bisection, if there's a very long test suite and it failed at some point in the middle, if you can't run just that, then it's going to slow down your whole bisection. So these are the kind of things that we're trying to explain and make people aware of, so we can hopefully scale better with people contributing tests and hardware. And yeah, it's like exploring the unknown, mapping the kernel. So that's basically summarizing what I've been mentioning a few times during this talk about the media subsystem. So we're building now the media subsystem branch, not very regularly because we're still turning this on, but the idea is to do it maybe every day or every week. And we're expanding the v4l2 test plan to cover more things. So we've done this on QEMU with Vivid and also on UBC video. And yeah, it's been great at improving test results, and also we use that as an example for tracking regression. So now if one test case in v4l2 compliance fails, you get this in an email report. It will tell you that started failing, or if it keeps failing, it will say, last time it passed was that version, it's been failing since that version, and now here it's still failing. So that's been a good dynamic there, and hopefully when we go to do the same thing with IGT, or there's also GPO testing, we might be doing things soon in this area. Hopefully we won't have to come up with completely whole different approach to testing.
Unfortunately you will.
Yeah, well, we'll see. Okay. So we found a couple of issues with UVC video. You can see the details. I'm not going to spend too much time on this, but basically it's a driver that's been in mainline since 2626. And if you're on the compliance test, you find that there are some tests that are failing, and you wouldn't expect that normally. So that's kind of interesting thing. If people had been using CI all the way, then I think this would have helped. It would have maybe pushed people to fix things earlier. So yeah, showing failures helps developers to fix them. So if you don't run the test suite, you think everything's fine and you forget about the problems. Okay, thank you very much. I think we have a few minutes left for questions. And yeah, all the pictures are Creative Commons or public domain, so you can find them here. Yes?
So, first question. You've got an automated method of identifying failures. Do you have an ability to allow the person looking to fix that failure to explicitly run individual tests on demand, or is it just wait for the next run to see whether it's passed?
Yeah, we don't have any. So the question is, right now we have this automated system that will test all the kernels automatically and find failures. Is there a way for someone to manually trigger a rerun of the test that failed? So the answer right now is no. So if you don't have the hardware, if you can't reproduce it yourself, then you're in trouble. You can't really fix it. However, if you push a change to a tree and you hope it's going to fix it, then it will go through the system. But that's a long loop. So it's possible, of course. It's just a matter of giving permission, giving access to people to labs, because Collabora has a lab, we'll have labs, and it's kind of your own hardware in your own environment, and it's giving access to someone. I mean, if you gave the whole world access to your lab, it wouldn't really it could easily go wild. So yeah, it's a hard problem to solve. If someone has an idea about how to do that, I'd be interested. Yes?
Are there any plans to integrate or do some kind of relationship with the syscaller or sysbot system? Syscaller, sysbot?
I think I've read about them.
From Google,
So what?
Syscaller with Z. Syscaller, sysbot.
Okay. So the question is, so these are made by Google, is that right?
Sorry?
Are they made by Google, these? Okay. So the question is, there are tools made by Google called Zscaler and Zsbot. And the question is whether there's any plan to integrate them in KernelCI. So I don't know right now. But if you have, I guess they can be used to run tests automatically.
They're just programs that run fuzzy tests.
Oh, yes, okay. Yeah, so yeah, that could be integrated. There's no plan right now, but I guess that would be a way of extending test coverage, so yeah, it could be.
How do you deal with random failures?
So what do you mean by... So the question is, how do you deal with random failures? So what do you... Yeah.
Let's say that a test has a probability of failing of 1%, and it's just what it is.
So if a test has probability of failing of 1%, so it's like intermittent failing?
Yeah. Can be a race condition, can be anything.
Okay. So, well, in that kind of extreme case, 1%, it's basically we don't really deal with them in a specific way. For bisections, there's something that can be done is run each iteration several times. So if the test fails, like most of the time in normal ways, you can request that the thing is run several times to be sure that it really passed or didn't pass. So if, also the bisections has some checks to check that the bad revision is really bad and the good revision is really good, and check that the result is actually failing, and if you revert that result that it's actually working. So these things, at the end they run 3 times. So if it was intermittent, if it was, normally it helps filtering them. But yeah, these are hard things to deal with.
So there's no report unless there is a bisection that actually succeeded?
There will be a report to say that it failed in the original test report, but a bisection report, you'll only get it if it found a commit that passed all these tests. And it's very difficult to pass all the tests and have a false positive. It can happen, it's really rare, it's like some weird combination of caching, trying to download some kernel builds and some weird infrastructure. Sometimes it can happen, but normally it doesn't happen like that. Okay. I guess there's maybe related to your question is about tests that are not hard pass or fail, but more like a measurement, like performance or energy consumption, because these, it's not just yes or no. So we don't really deal with these at the moment, and they're really difficult to bisect because the curve over time can change many times, and it's hard to find where it dropped. But these are things we can start doing.
It's called EasyBench.
Okay.
I've been developing it for 3-4 years, and it can auto bisect anything: boot, performance, changes in rendering of games, or performance.
Okay, what's it called? DC?
EasyBench.
EasyBench. Okay, so there's a tool for that called EasyBench,
It's
like
a
easy.
reimplementation of bisecting, and if you've got, let's say, you've got 10,000 tests that you execute, and then 300 of them failed, it's not going to bisect 300 times. It's actually going to bunch them together.
Okay.
Yeah.
Sounds good. So maybe something to look at.
There's more things that we can collaborate on.
Yeah? Great. Question there? Yeah?
Now you talk about that, like, what's like expanding the hardware or just getting the right hardware in your hand. But maybe you've run into programs with hardware that were difficult to test, or something that was not made for that. You run into trouble trying to expand the run of the hardware?
So the question is, do we have issues trying to expand the range of hardware because some hardware may be difficult to automate? Yes. So yeah, there's especially, I think Kevin is an expert in doing that, in taming boards that don't want to be automated by having special workarounds to, because some boards, like if they are basically like Android phones turned into a dev board, they would only support fastboot to flash a kernel on them. So you need to, if you take a kernel image, you need to turn it into something that you can flash and then flash that. Whereas most of the boards, normally what we like to do is use U-boot or UEFI and then use TFTP to download the kernel and access the file system, like a RAM disk over TFTP or NFS. So yeah, there's plenty of boards that are causing issues with that. So there are a few ways around it, but yeah, every one of them is different. So I guess the key normally is to have like a special tool to prepare the binary and handle the hardware in a very specific way.
Okay, so we're out of time for more questions, so thank you.
Thank you very much.